Our next and last speaker today is an American aerospace engineer and author of Mars Direct and president of the Mars Society. And he is renowned for his advocacy of manned Mars exploration. And as the architect of the Mars Direct plan, a strategy aimed at reducing the cost and complexity of Mars missions. This approach emphasizes in-situ resource utilization, proposing the extraction of oxygen, water, and rocket propellant from the Martian atmosphere to support surface operations and enable a return journey. He has also been critical of asteroid-based initiatives and moon return missions, arguing that Mars provides superior advantages, including sustainable resource utilization and long-term human settlement potential. Ladies and gentlemen, it's my pleasure to announce that here he is with us online on our conference, live and exclusive Mr. Dr. Robert Zubrin. Robert, can you hear us from Budapest?
Yes, I can. And thank you very much for inviting me to address your conference. I'm speaking to you from Colorado, where I live.
Wow. Lovely. So good morning to you. It's a lovely sunny afternoon here in Budapest, Hungary. And the stage, the screen, and the audio is yours. It's our pleasure that you can join us. Thank you very much. So we can hear you loud and clear. Thank you very much for being with us. And the stage is yours.
All right. Well, thank you. Okay. So I'm going to talk about humans to Mars. And may I ask, how long do we have here?
Let's say 30 minutes, and I'm sure that there will be some questions if you would be so kind to answer the questions possible.
Okay, very good.
Thank you.
So I'm going to talk about the human exploration and settlement of Mars. I'm going to talk first about why, and a little bit about how, and then open it up for questions. Okay. And by the way, if you want to know more about what I have to say, I've written a book called The Case for Mars that you can get on Amazon that goes into much greater detail. And I have a more recent magazine article that's available online called something like The Mars Dream is Alive. It's published by a publication called The New Atlantis. All right. So why Mars? There are three reasons, in my view, why we should commit ourselves to the exploration and settlement of Mars. These are for the science, for the challenge, and for the future. Okay. First of all, there is the science, and this is the one that the various space agencies like NASA, ESA, take seriously. They don't adequately, for the most part, address the second, and certainly don't address the third. But we'll talk about the science first. It's biology. It's the question of the origin of life, okay? And it's a question of understanding what life is. So here's the thing. We have a critical experiment with Mars. The early Earth and the early Mars were twins. Both were rocky planets with liquid water on their surface, a temperature appropriate for liquid water, various sources of energy, including sunlight and volcanism and meteoric impacts, lightning, and a CO2-dominated atmosphere. The early Earth did not have oxygen in its atmosphere. It had carbon dioxide where the oxygen now is, as, of course, did Mars. And we know that life appeared on Earth. So the question is, did it appear on Mars? And this is fundamental. This is, and it appears on Earth virtually as soon as it can, by the way. We have fossils on Earth going back 3.5 billion years, and biomarkers, that things indicative of life going back 3.8 billion years, which is practically right to the end of the heavy bombardment. So as soon as liquid water appears on Earth, life appears. So the question is this a lawful process, a deterministic process, which we don't quite understand yet. But, is it like, here in Colorado last night, it was well below freezing. If I put out a cup of water outside, it would have turned to ice by morning, and there is no doubt about that. And the the, the so is the formation of life from chemistry a process of that kind that is predictable when you have the appropriate physical conditions? Or is it a matter of freak chance? Is it a 1 in a billion thing that somehow the chemicals came together to form these very complex and intricate, DNA molecules, as some people argue, in which case, if it's the first, life is everywhere in the universe because we now know from the Kepler Space Telescope and other exoplanet instruments that most stars have planets. Planets around stars are not the exception, they're the rules. It's a very unusual star that does not have planets. And at least 20% of stars have Earth-sized planets in their habitable zone. That is the correct zone where you have the right amount of sunlight to have the temperatures suitable for liquid water. 20%. So 400 billion stars in the Milky Way galaxy. 20% of that is 80 billion stars have Earth-sized planets in their habitable zone. If life forms wherever you have a good planet, then life's all over the place. And since the entire history of life on Earth is one of development, from simple forms to more complex forms, manifesting, well, all sorts of new capabilities, but these include, within the broad set of adaptations, capabilities for greater amounts of activity and intelligence, and in fact, ever more rapid evolution. Evolution on Earth has not reached its end. Evolution on Earth is accelerating and has been accelerating for the past billion years, dramatically, exponentially. And so if we can find even fossils of life on Mars, it would prove that not alone that we're living in a universe that is dominated by the phenomenon of life. Okay, now furthermore, there's something else to be found, because I believe that if there was ever life on Mars, it's still there, because life finds a way to adapt to changing conditions. The earliest life forms that evolved on Earth, to them, oxygen was toxic. So, because the early Earth didn't have oxygen, they evolved in an oxygen-free atmosphere. And when things changed, because green plants put oxygen in our atmosphere, or green microbes, they couldn't live on the surface anymore. So they went underground. Okay. These anaerobic organisms retreated from the Earth's surface into the groundwater 3 billion years ago. And they are still there today. Okay. They've seen the trilobites come and go. They've seen the dinosaurs come and go. They've seen the mastodons come and go, and they're going to see us come and go. But they're still there. So similarly, while there was liquid water on the Martian surface 3 billion years ago, there is not today. However, there is liquid water underground. Okay. And as the surface became unacceptable for life, I believe that the microbes would have retreated into the groundwater. And if we can send human crews to Mars and set up drilling rigs, because these liquid water could be as close to the surface as 500 meters, and we bring up samples of liquid water and look at the microbes in it, we could determine what their nature and structure is. Are they the same as Earth life, or are they different? Fundamentally different. See, all Earth life at the fundamental level is the same. We all use DNA and RNA as our information alphabet. Okay, whether it's bacteria or horses or mushrooms or people, they all use DNA and RNA. That's it. So, but is that the universal alphabet? Is that the universal information system of life? Here I am, I'm an American, I speak English. We use the Latin alphabet. In Hungary, your language is very different, but you also use the Latin alphabet. Okay, if you go a bit further east, there are people who use the Cyrillic alphabet, which is got some of the same letters and some different letters, but it uses the same general type of system, phonetic system, from the Phoenicians that even the Israelis, the Hebrew alphabet, the Arab alphabet, they look completely different, but they all use the phonetic system. But if we go even further east, we come to China and they use an alphabet. Well, it's actually not really an alphabet. It's a different system altogether for recording words. It works on completely different set of principles. It is not a method of reproducing sounds. It is ultimately derived from pictures. But it works. You can write books in it. So the question is life in the universe, does everybody use the Latin alphabet, or are there different information systems out there? You know, just like at one time, computers used mechanical gears and things like this to perform a calculation. And then later on, they used, electric relays, and then vacuum tubes, and then transistors, and now they use chips. And people are working on DNA computers and quantum computers, which will be absolutely revolutionary compared to the silicon computers that we are now using. The point is, as the underlying information technology changed, the computer kinds of computers you could build changed radically, radically. And so there could be radically different forms of life. And so this question of what is the nature of life, right? In other words, right now, if someone was only acquainted with Western Europe and North America, they would think an alphabet is the Latin alphabet, period, full stop. That's what alphabets are. Okay. But of course, we know because we have some awareness of the world that alphabet is a broader category than the Latin alphabet. Similarly, life could be a much broader category than what we currently know on Earth. And this is important not just for scientific and philosophical and academic reasons to understand the nature of life, but for some very practical reasons. Biotechnology is going to be one of the primary technologies of the 21st and all future centuries. And if we can gain an understanding of principles of biology that are much broader than those that we're currently limited to, the technological implications could be fantastical. Okay, it could enable things like nanotechnology and so forth. So there it is. So the science, and we will only know this by going to Mars with people, and I would argue by going to Mars in force with people, with lots of people. Because, for example, Europeans made many natural discoveries in North America. And if they had limited their presence to North America to a few exploration voyages along our East Coast, these discoveries would not have been made. So the reason why we know so much about Earth is because we have settled it. And if we had stayed a few tribes in the Kenyan Rift Valley, which is our natural habitat is not Europe or North America. No human being in the true state of nature, that is, without any technology whatsoever, without clothing, which is a technology, for example, could survive a single winter night here in Colorado and perhaps not in Hungary. I don't know. But clearly, we are immigrants to most of the world where we now live, and we can live there because we have mastered all sorts of technologies that made the Earth habitable for us. And I'll come back to that point. Okay. The Earth is not our natural habitat. The Kenyan Rift Valley is our natural habitat. We have become a global species because we have invented the technology that makes the rest of the world habitable to us. Ice Age Europe was not habitable to original people who did not yet have fire, for example, or clothing, or weapons that could kill at a distance and thus enable big game hunting which is a source of food in the winter when there are no fruits and berries around, um, and so forth. Or language, which is a technology which is necessary for being able to engage in big game hunting and other difficult activities. So, okay, we'll come back to that. All right, and then there's the challenge. Okay, I'll be relatively brief on this one, which is I believe that societies are like individuals. We grow when we challenge ourselves, we stagnate when we do not. And I believe accepting the challenge of exploring and settling Mars would be an extremely positive challenge to every nation that chooses to engage in it. Okay. In particular, it would be enormously healthy for the development of scientific talent. It would challenge every young person, every boy and girl, with the incredible call to adventure. Learn your science, and you could be an explorer, a pioneer of new worlds. And from that challenge, we would get millions of scientists and engineers and doctors and medical researchers and technological entrepreneurs and inventors and all this kind of thing, who are the people that do advance the human condition. Okay. And so there can be nothing more powerful to advancing the human condition, to meeting all our needs here on Earth, than the generation of scientific talent, scientific and technical talent. There's nothing more better to do that than that. And the Humans to Mars program would do that. We saw this in my country in the 1960s. Okay. I was around in the 1960s. I was a boy while we were doing the Apollo program. And the number of scientists and engineers created in the United States, the number of science graduates in the United States doubled in the 1960s during the Apollo period. And this was at every level of education, high school, university, PhD, doubled, and in some fields tripled. Because of this call to adventure. And in fact, I was one of those people. I was one of, if you will, Apollo's children. And by the way, and that increase in scientific talent immediately stopped as soon as the Apollo program stopped in the early 70s. In other words, we went like this. If you look at the graph, you just go like that, and then it goes like that. And in fact, the number of science graduates per capita declined after Apollo because the number of graduates stayed the same and the population increased. But this is something that Europe in particular could benefit from enormously. You know, for the past half century, Europe has told its most talented young people, you want to do planetary exploration, you should emigrate to America. This has been beneficial to America. This has been harmful to Europe. And so if people ask you why we should do this, aren't there more practical things for us to do? The answer is no, there are no more practical things for you to do. You really need this. So there it is. And now I happen to be unusual in that group of Apollo's children, of all those science graduates we had in the 1960s, in that I actually ended up working in the space program. But the large majority did not, but that was fine. They went and created the computer revolution. They built Silicon Valley. They created the internet. Okay, that's what my generation of young scientists did. And look at the incredible amounts of wealth and transformation of the human condition that has enabled, including my addressing you in this conference right now. Okay, which is being one of the outcomes of all that. When I was a kid, my father did engage in some international business, and so he had occasion to do long distance phone calls, even to Europe, and it would be arranged well in advance, and they would keep it as short as possible because it costs like $10 a minute. And now you can just go on Zoom and talk to a conference, and no one's counting how much it's costing by the minute, because it's not costing anything by the minute, and so forth. So it's enabled a much more global civilization. And then finally, there is the future. And I wish to talk about the future in a number of contexts here. Two, actually. One is the ultimate future, and the other is the immediate future. Now, I believe that if we accept this challenge and do what is necessary to establish those first human colonies on Mars in our lifetimes, okay, that will then, as is being discussed in your conference, go forth and eventually terraform Mars, transform it into a fully living planet, which will support actually probably many new branches of human civilization, many new nations, new languages, new cultures, new literatures, many new sources of creativity, of technology and invention, as the various nations of the earth have each to various degrees contributed their genius to human progress through the inventions that they have made and the literature that they have created and all the rest. This won't be the end of it at all. I believe that if we do this, 500 years from now, there will be human civilizations on thousands of terraformed planets orbiting thousands of stars in this region of the galaxy. Innumerable new nations and civilizations making all sorts of contributions to science, art, literature, you name it. Okay, and this is something totally grand, glorious, and if you have the capability of doing something grand and glorious and wonderful, then you should. Then you should. Okay, and so we should. Okay, and this is the time when this will begin. This time, there was a book written about 30 years ago that was, for one reason or another, a big seller, maybe because it was so controversial. It was entitled The End of History, in which a philosopher argued that now, in 1990, we've reached the end of history because everything important has already been done. So, here we are. Well, we haven't reached the end of history at all. We're living at the beginning of history. Okay, the beginning of history. I'm an American. If you ask any American, almost any American, even with people with very poor educations, what happened in the year 1492, they will say that is the year when Columbus sailed. Okay, and that is correct. It is the year. Now, of course, you as Europeans know that there are many other things that also happened in the year 1492. You probably know things about what happened in Hungary in 1492. And those of you who know a lot about European history will know that in 1492, England and France signed a peace treaty. The Borgias took over the papacy. Lorenzo de' Medici died. Something horrible undoubtedly happened in Russia, because it always does. But but what we remember from 1492 is Christopher Columbus, that an Italian weaver's son sailed across the ocean in 3 small ships. That's what we remember from. That's what counts to anybody who lives in the Western Hemisphere, Americans, Mexicans, Brazilians, you name it. That's what we know. And 500 years from now, to those people living on those thousands of planets everywhere else, what they will remember about this time is that this is when people first set sail for other worlds. That is what they will remember. Only historical scholars will know who Donald Trump was. Okay. Average people will not know who he was, or Putin, or any of these people. Or Orban. Okay, that is what they will remember. Okay, so this is what is important about our time. However, we do live in our time. And how does that ultimate future affect the immediate future? It affects it in a big way, because how people conceive of the ultimate future determines how they look at the present and the immediate future. And the question is this: what is the main threat to human civilization today here on Earth? Now, if I asked this of an audience, say 5 years ago, most people probably would have said global warming. Uh, and there's maybe a few people that still say that. But and while I believe global warming is entirely real, it is a technical problem that can be solved with the widespread adoption of nuclear power. Uh, uh, some people might say resource exhaustion. Okay, we're running out of oil and copper and other resources. Well, that's nonsense, actually. There's far more resources available per capita today than there was, say, 50 years ago when the Club of Rome wrote their report saying we're going to run out of everything by the year 2000. Uh, and infinitely more resources available to people in the year 1600 before the Industrial Revolution even began. No, we're not running out of resources. The thing that threatens human civilization today is bad ideas. And in particular, which is the same bad idea that in a variety of forms threatened human civilization and caused innumerable gigantic catastrophes in the 20th century. And that is the idea that there isn't enough for everyone. So we need to kill them either in order to take what they have or to kill them before they come and take what we have. This is this idea of limited resources puts all against all. Okay. This is in a variety of forms. It came in different ways, in different countries, in different times, but it's all ultimately the same idea. There isn't enough for everyone. So there's going to be a war. There must be a war. And the question is, should it be sooner or later? Well, to one side or another, it's always better to have it sooner. You take 1912, okay, Friedrich von Bernhardi, the chief intellectual of the German General Staff, wrote a book entitled Germany and the Next War. It was a bestseller, by the way, and which he said, well, who's going to get Eurasia? It's either us Germans or the Russians. Okay, we're the two big players here. It's either us or them. There's only so much here. So we're going to have to fight it out with them. And should it be sooner or should it be later? He says, let's make it sooner because they haven't industrialized yet. And so we can defeat them if we fight them now. If we wait too long, they will have industry and they'll have more numbers and they will win. So let's have a war. And so your own Conrad von Holzendorf took advantage of the assassination of the Archduke 2 years later to force the issue and initiate the First World War, which was a catastrophe. And if you think about it, an insane catastrophe because Europeans were living better in 1914 than they ever had before in human history, and they almost destroyed themselves fighting over limited resources. Okay. And then again, Hitler later, even more hysterically, declaring Germany needs living space. Okay. Okay. Germany did not need living space. Germany today is smaller than the Third Reich and has a larger population, but it has a much higher standard of living, not because they were successful invading other countries and exterminating the people so they could steal their cows. Okay, they were ultimately unsuccessful in that project. And if they had been successful, they'd be much poorer today than they actually are. They're living far better than they were in the 1930s because of the advance of science and technology, which has been a global project to which people from all nations, including very notably people they were trying to exterminate, were contributing to. And but that doesn't seem to make sense to people that the world's resources are unlimited, which they are. Okay, but I happen to know today that we're being threatened with the exact same ideas. I happen to know people in positions of high responsibility in the American national security establishment who believe that war with China is inevitable. Why? Because there's over 1 billion of them, and if they all start driving cars like us, there's not going to be enough oil in the world. Okay? And you can bet your last penny that there are people in Beijing who look at this issue from the other side of the chessboard and think pretty much the same kind of things. Okay. And if this kind of thinking is allowed to prevail, there will be war. And this time it won't almost destroy us, it will destroy us. but it's a false point of view. Okay, it's a false point of view. The idea that people are competing for resources or that nations are competing for resources is false. Okay, the reality is that we actually are a family of nations, a very disorderly family to be quite sure, but nevertheless of different nations making different creative contributions to the overall progress of science and technology, which is what expands the amount of resources available to us. And that's why, as the world's population has gone up, the standard of living has gone up, not down, exactly the opposite of what Malthusians project. But people don't see that because they say, here it is, it's the Earth, it's just this big. Okay, sooner or later, there's not going to be enough for everyone, sooner or later. So to try to argue with this is try to convince someone who is mathematically illiterate that there's an infinite number of points in a 1 centimeter long line segment. Okay, you say to someone who doesn't know mathematics that there's an infinite number of points in a 1 centimeter line segment, they find that idea absurd. Not only wrong, but just crazy, nuts. That's impossible. Okay. But you can convince anyone that there's an infinite number of points in a line that extends infinitely in both directions. And this is why this vision of the ultimate future is critical. This undermining this idea of limited resources. The idea of limited resources convinces people that war is inevitable. And by the way, the idea that war is inevitable is the principal justification advanced by tyrants for their tyranny. For instance, Putin in Russia. Okay, that Russia needs the Silnaya Ruka. It needs a tyranny because it's going to be war and we have to be strong. And so we must suppress all dissent. It cannot be allowed so we can be strong and defeat the enemy. This is okay. So tyrants want people to believe in the necessity for war. And the most convincing argument for the necessity for war is the conceit of limited resources. So by showing that resources are unlimited, that there is in fact an infinite future, we undermine the thesis that war is necessary and therefore that tyrannies are necessary. And since it's the tyrants who actually want war, since it is necessary to justify their power, okay, we undermine them, we undermine war. Okay, so this is the most important thing. By projecting this vision, it may seem to some people that people like you, the organizers of this conference, you're talking about terraforming Mars. How far from reality can you possibly be, right? Okay, shouldn't you be talking about, something that's more immediate, how to solve the unemployment problem or get costs down or something, or perhaps getting medicine to poor people in Africa. Okay, those are all worthwhile things, but I have to tell you, this thing of refuting this idea, okay, is the most important thing, because if it is not refuted, we are going to be destroyed, okay? We are going to be destroyed, and also those poor people in Africa are going to be destroyed along with us too. Okay, this is the key issue, okay? Destroying this evil idea, because ideas have consequences. Evil ideas have evil consequences. So this is a war of ideas and the proposition of terraforming Mars. And then, of course, if we can terraform Mars, okay, that means that many more planets orbiting other stars, which are not quite right for humans now, but which are terraformable, will become worlds that people can make habitable. Okay, and this is what we can do. And we can continue the work of creation. Okay, and by so doing, prove the worth of the human race and implicitly, therefore, every member of it. So I think I'll leave it there and take questions. Thank you.
Dr. Zubrin, thank you very much. This is very, very interesting. Can I start? Because I have the advantage that I have the microphone right now here in my hand. So we all heard the inaugural speech of President Trump. And the target was very clear. Put the stripes and the stars flag onto the surface of Mars. So do you think that can bring the new golden age or golden era of American space science? What do you think about this one?
Okay, well, there's an opportunity here and also a hazard. Okay, so Trump, obviously influenced by Elon Musk, who funded his campaign, has declared his objective to send humans to Mars. And this is an opportunity to get a humans to Mars program started. And I believe we will get a humans to Mars program started. However, this has to be put on the correct intellectual foundations, or it will ultimately fail. It will fail in many ways. I mean, simply in terms of domestic American politics, it will fail because Musk has now defined himself in an extremely partisan way. And if this project is viewed as his project and not our project, it will be destroyed as soon as the fortunes of political warfare shift. Okay? We are going to have another election in this country in 2026. And the Democrats, who now hate Elon Musk, and I say hate, I mean hate, they are very likely to take either the House or the Senate. We have, two different branches of our Congress, and if they take either one, they will stop all funding for this program if it is conceived of as Elon Musk's pet program. Okay, this has to be viewed as at the very least, as an American program, not a Musk program, and preferentially, okay, and this is going to be very difficult to do, given the nature of the Trump administration, a program of the West. Okay, that is this civilization that we share, this Enlightenment humanist civilization committed to human freedom, reason, and dignity, which is the basis for this incredible civilization that has emerged in Europe and America and a few other countries over the past, 400 years. It's been nothing like it. It's really great. And it's a brotherhood that we have. Ideally, this should be a project of this family of nations committed to this ideals. Now, there's a problem with Trump with respect to that because Trump does not believe in this concept. He is the first American president since World War II and possibly ever who hasn't believed in this concept. And so that's a problem. Americans, by and large, still do believe in this concept, so you should know that. But it has to be at least understood as an American program and this. And I think that, well, first of all, there's also a number of lies being said. Musk is saying he's going to land people on Mars in 2028. That is not going to happen. And in fact, I happen to know that SpaceX is making no serious preparations to land humans on Mars in 2028. Okay, they are working very hard on the transportation system, the Starship, but they are not working on any of the surface systems. Okay, now, but it is possible if they committed themselves to it and worked very hard to land a Starship on Mars with a crew of robots, rovers, and helicopters, and things of this sort on Mars, land an entire robotic scientific expedition on Mars. I'm not predicting that they will do this. I give them about 1 chance in 4 of being able to do it if they decided to do it, but that's a chance. And if they didn't succeed in 2028, they could probably do it in 2031, which is the next launch opportunity after that. Now, doing that, a robotic expedition to Mars, okay, instead of landing one rover on Mars, land 30 and 30 helicopters as well, and not just little ones like Ingenuity, but big ones that can carry lots of instruments and experiments, and also drilling machines and other stuff. So you show that this heavy lift capability, which is needed to support human expeditions to Mars, can also increase the capability of the scientific exploration of Mars by about a factor of 100. This will win over the science community, and it will win over the science interested part of the public, which is very strongly represented among Democrats, among, you might call, the left half of our political spectrum. And it could get broad public support, that it wouldn't be understood as an Elon Musk thing to create a colony on Mars so there will be survivors on Mars after human civilization is destroyed, which is what he says, and which I believe is the wrong motivation for going to Mars. We do not go to Mars out of despair. We go to Mars out of hope. Hope is a virtue. Despair is the worst of sins. Okay? It is a sin. It is a vice. It is the worst of sins, because if you embrace despair, you cannot do anything. Okay? And so we do not go to Mars so that there can be a place for a few survivors after the Earth is destroyed. That is a repellent justification. We go to Mars to expand the capacity, the creative capacity of the human race to deal with all challenges so the human race is not destroyed. Far from it. That the human race can then bloom and flourish and spread all over. So the ideological foundations of the program must be corrected if this program is to succeed. Okay? And in my recent article that I mentioned when I first began my talk, The Mars Dream is Alive, in the New Atlantis, I discuss this very issue. Okay, and I also discuss some technical issues as well, because I believe that in addition to Starship, which we need something kind of like a Starship, but much smaller. I call a star boat. Okay, because if you had Starship plus Starboat, you could do both lunar and Mars missions, putting Starship tankers in orbit around either the moon or Mars and sending the Starboat up and down, and it would be a much more efficient mission architecture than the one that SpaceX is currently proposing.
I see. All right. So we will definitely read this article. Dr. Zubrin, I would open the floor now to the people, the folks here. Please, do you have any questions to Dr. Zubrin? Yeah. Raise your hands, please. We will give you a microphone if we find one. Yes, thank you. Can I get your name and the representing country and/or company? Thank you.
Hello, my name is Szabolcs and I'm from Space Junkie. We are a YouTube channel. It's a great honor to speak to you, sir. Thank you for taking my question. So my question would be that how confident are you in the Moon project, Artemis project? So now they are cancelling, it looks like they are cancelling SLS rockets and Starship is taking shape. Do you think the Artemis program is essential for going to Mars, or can it be done simultaneously, so in parallel, and building a sustainable base on the Moon, and then in the same time focusing on Mars as well? Thank you.
Okay, those are excellent questions, and once again, I address them very directly in the article that I've mentioned to you. But let me answer you right now. The Artemis is an extremely badly designed program. Okay, it is the wrong goal done in the wrong way. Okay, NASA has two fundamental modes of operation that different programs operate on. It has what I call a purpose-driven mode and a vendor-driven mode. And the difference is that purpose-driven programs spend money to do things, while vendor-driven programs do things in order to spend money. Okay. Apollo was a purpose-driven program. Its purpose was not scientific, it was geostrategic. It was to astonish the world with what free people could do. Okay. But that said, it had a purpose, and it went after that in the most efficient way possible. Okay. Human nature was no different in the 1960s than it is today. There are always people that when the government is spending a lot of money, want some of it for themselves. Okay. There are always people that when you start a program, show up and say, you have a great idea, but you can't do your program until you do my program. So you need to give me money. And there were plenty of them that showed up around Apollo, and they were told to go away. Artemis, on the other hand, is the opposite. The methodology adopted for Artemis was, we can get a lot of support for our program if we give a lot of people money. Okay, so there'll be a lot of Artemis fans if a lot of people have a piece of the action. Okay, and so if you look at the design of Artemis, if it can be called that, you have 5 major flight elements: SLS, Starship, Orion, the National Lander, and the Lunar Orbit Gateway. Okay, and these things do not fit together. Okay, unlike Apollo, where you had the Saturn V, the command module, and the LEM, were all designed as piece of a plan. They were not designed as individual projects that somehow will make these things work together later. Okay, when you build a house, you usually have a plan, and then you buy the parts you need for that house. Okay, you don't just, every weekend for 3 years go out and I don't know if you have garage sales in Hungary, but in the United States, people put things out in front of their houses and on weekends, and they sell things, and you say, oh, I like that, let's accumulate a pile of things, and then later on see if we can put them together to build a house. No. Okay, so Artemis is just crazy. Okay, it's a crazy plan. It makes no sense. And the SLS even internally makes no sense. It has the wrong upper stage for the lower stage. So while it has the takeoff thrust of a Saturn V, it has half the payload capability. And its payload capability is too weak to put an Orion in lunar orbit with enough propellant to come home, even without a LEM, a lunar excursion module, let alone with one, where Saturn V could do the whole job. Okay, so the lunar orbit gateway serves no purpose. The Orion is too big for the SLS. The Starship, if you have Starship, you don't need the SLS, but Starship really is it's an excellent vehicle for surface to orbit launch and even translunar injection launch, but it is a horrible vehicle for lunar ascent, okay, which is what the role they've given it to, because it weighs 100 tons compared to the Apollo lunar excursion module weighed 2. Okay, so they create a lander because a rival contractor to SpaceX was very angry that they hadn't gotten a big contract, but they didn't even bother to tell them that they should use methane oxygen propellant in their lander so it would be compatible with Starship. The National Lander uses hydrogen oxygen. If it used methane oxygen, they could have used the Starship as a tanker in lunar orbit and gone up and down with the lander. That would have made sense. But no. Okay, so Artemis is in need of a massive rationalization. And the correct architecture for Artemis is Starship plus Starboat. That is a small methane oxygen vehicle, fully reusable, okay, with a delta V capability of velocity change capability of at least 4 kilometers a second, because to go down from lunar orbit and back up to low lunar orbit is 2 kilometers a second down, 2 kilometers a second up, 4 kilometers a second. There's no reason to have the gateway at all. It's stupid. Now, the same combination could do Mars, because the delta V to come down from Mars orbit to the surface is almost zero, because there's an atmosphere that can slow you down. The delta V to go up from the surface to orbit is 3.8 kilometers a second, which is to say almost the same as the round trip delta V from lunar orbit to the surface. So the same starboat can do both. So you could do the moon and Mars with both Starship and Starboat. And this would remedy the other problem with Musk's Mars mission architecture, which is he wants to make propellant on Mars for a direct return from the surface using methane oxygen produced on Mars. But since the Starship is so big, to send it back from the Martian surface requires 600 tons of propellant, which would require 600 kilowatts, which if you did that with solar panels would be 12 football fields of solar panels you'd have to put on Mars and keep the dust off them to do that. If you use a starboat, it's much smaller, and also the delta V is less. You only need 50 tons of propellant. Okay, so instead of 600 tons, 50 tons. A much smaller solar array or nuclear reactor, if you're going to use a nuclear reactor, which I believe you should. Okay. Furthermore, Starboat, okay, is the right vehicle for going long distance travel on Mars, surface to surface. Okay, you don't want to use Starship for that. That'd be a gigantic propellant production thing. But in other words, if you want to send exploration teams from the Mars base out to faraway places, Starboat is the way to go. Okay, so not only do you have a Moon-Mars program which is coherent, both internally and with respect to each other, it has far more exploration capability on Mars itself. So that's what I would do.
Dr. Zubrin, thank you very much. Any other questions, please, from the floor? Yes, we have another question. Thank you.
Good afternoon. My name is Zuzanna Benyó from Space ABC. I'm a space economist, but also a space nutritionist. My question is, what would you recommend to the so-called emerging space nations to advance space and join the international partners?
Well, are you talking about a nation like Hungary, which is an advanced nation, but a small one? Or are you talking about developing nations in Africa which are not advanced technologically?
I'm interested in a nation where there is advanced technology and knowledge.
Okay, well, okay, so let's take Hungary as an example, since that's where you are, and which is a country with advanced technology, but which is small. Okay, I think that Hungary should launch a robotic Mars scientific exploration mission. Okay, I really do. I think Poland should. I think, you name it. I mean, look, the United Arab Emirates did a Mars orbiter. And that's not even a real country. It's more of a gentleman's agreement. We did the Mars Global Surveyor orbiter. It cost $150 million. Okay, that's the price of building a nice shopping mall. Okay, there's innumerable projects done on that scale. It is entirely within the budget of a country the size of Hungary. Now, you can do it through a national space agency, or you could do it with only a small participation, which I'll get to, from the National Space Agency, but by promoting entrepreneurial space. Look, there's a company called Rocket Lab, which is a New Zealand company, which has reached orbit. and in fact is planning on sending a probe to Venus in the near future. Okay, now New Zealand, I don't even know if they have a space program, but they have interplanetary capability because they promoted the development of an entrepreneurial company. And see, here's the thing. One of Musk has done a lot of things with respect to space, and some have been positive and some not so positive. But one of the very positive things that he's done is made clear the value of entrepreneurial space. The success of SpaceX has proven that a small, well-led entrepreneurial team can do great things in space. In fact, it can do things that was previously thought that only the governments of superpowers could do. Okay. Uh, and okay, so he's created a company, and of course Bezos created a company. But Rocket Lab was not created by billionaires. Rocket Lab was created by working engineers who managed to secure investment. Okay, and then they proceeded to develop a working launch vehicle company. I believe that the Hungarian government should promote an entrepreneurial space industry in Hungary. Okay, and seek to use it to do a interplanetary mission. But even before that, the UAE, when they did their planetary mission, they launched on an American launch vehicle. Well, that's fine too, because you could launch on a Falcon 9. Okay, and so there's your launch vehicle. And then it is certainly within the competence of Hungarian scientists to build a spacecraft. Okay, that is the thing that would be launched to Mars. Okay, and I think that you should. And this is where I would say that the Hungarian government could form a space office and say, we're going to do a Mars orbiter, but there's so many different things that haven't been done on Mars. There's life detection experiments. No one's flown a life detection experiment on the Martian surface since Viking, 1976. There's things you can do from orbit that haven't been done. There's been some ground penetrating radar work, but there's a lot more that could be done. Different frequencies of radar have different capabilities for going deeper or more refined. Just any number of things you could do. For every instrument that made it onto Perseverance rover, there were 10 proposals that were not accepted, but which were perfectly good proposals, but they could only take 6. Okay. And so to design and build a spacecraft. Now, the easiest kind of spacecraft in this context to make would be an orbiter. Okay. But you could also consider a rover. Now, which you could develop yourselves, or perhaps team with Poland. The Poles have considerable expertise with robotic rovers. The Mars Society holds rover contests in the desert at our Mars Desert Research Station every year. And basically every year since about 2008, a Polish team has come in first, second, or third, and sometimes first and third. And in fact, the Polish Mars Society actually holds something they call the European Rover Challenge. Usually happens around September in some Kielce or someplace like that. Anyway, but you could do it yourselves, or you could team. The problem, you see, obviously ESA could do it too, but the problem is the ESA structure is so unwieldy. And really, it doesn't take an entire continent of nations to do an unmanned probe to Mars. It can be done by individual nations, certainly of the size and competence of Hungary. And also, there'd be another effect of Hungary doing it. Okay? If Hungary does it, it would really put the question to the French and to the British and to the Germans, okay, and even the Argentines. If Hungary can do it, why don't you do it? And so this would be really great. I'd like to have an Olympic, like the Olympics. They're competitive, but they have a very positive spirit to them. I'd like to have an Olympic spirited competition as who can win the most honors in achieving scientific discoveries on Mars. Okay, and it's open to all nations, even to nations that are geostrategic rivals. Let China show what it can do. Fine. Okay, let's have a competition of this kind. And I think it would be extremely valuable if a nation as small as Hungary did it, because it would absolutely force somewhat larger countries such as, Italy, Britain, France, Germany, Brazil, Australia, Canada, why aren't you doing this? Let's all do it. And having different teams with different ideas as to what is the best approach. We haven't flown balloons on Mars yet. You can fly balloons on Mars, but no one's done it. Okay, because the in-crowd at Jet Propulsion Lab, they're not into balloons. But maybe you will be. Do a Mars balloon mission, a Mars airplane. So yeah, I would say this. Now, also, you can, of course, do what you undoubtedly have done, is put instruments on other people's Mars missions, on American missions, on ESA missions. But I think we could greatly pick up the pace here if we had individual nations doing this, and more centers of creativity in the game.
Thank you very much. What a great idea to create an Olympic-like competitions for these sciences and these technologies, and that's an interesting idea. Any questions? Any more questions? Yeah, one more question from Germany.
Hello, Mr. Zubrin. My name is Victor Meyer from the Exploration Company. We actually plan to build the space boat you were speaking about. We're actually building an engine which is based on liquid oxygen methane with the delta V. But this is not the question. My question is actually, what would be the key technologies that you see are missing to get us to Mars today, and what would be the timeline, the roadmap you think we can achieve that?
Okay, well, okay, so there's two different issues here, which is technology and hardware. Okay, if we're talking about, a starboat, methane oxygen reusable ascent vehicle, in the 10-ton class instead of the 100-ton class, like Starship. Okay, that's something we need. That's not a fundamentally new technology. That is an application of technology to create a specific hardware item, which we need. Okay, we absolutely need it. So I hope that you can develop it, or I hope that Europe can step forward and develop it, and then come and partner with the American Mars program, bringing Starboat and Starship. Let's do it together. But in terms of technologies, okay, there's two different questions here. There's technologies for human expeditions to Mars and technologies for settling Mars. Okay. Now, I would say in terms of technologies for human expedition to Mars, the most important one we need is surface nuclear power. Okay. And depending upon the design of the ascent vehicle, the size of the reactor could be as small as 50 kilowatts if it's doing a starboat to Mars orbit, or it needs to be 600 kilowatts or perhaps even a megawatt if you're doing Starship as your ascent vehicle and it wants to do direct return to Earth. Okay? So, but you need surface nuclear power. Because, all right, well, using surface solar power for the Starship as a return vehicle is impractical. It's ridiculous. Now, if you went with Starboat, you could reduce it from 13 football fields of solar panels to, 2, um, which is still kind of high. Um, but also the issue with solar panel on the surface of Mars, it's not that it can't work, it can. The Spirit and Opportunity rovers both use solar energy, but they had to go dormant for months at a time when the dust storms came, because you can have dust storms, which, while unlike, in the movie The Martians, the windstorm comes, it knocks everything down. That's not realistic because the air is too thin for it to have such force. But it does have enough dust to negate solar energy. So solar energy is unreliable. And while a Mars rover can simply decide, well, I'm going to do nothing for the next 3 months until the dust storm ends, humans need power every day. And and even on Earth, one of the principal weaknesses of solar energy for grid power is, like this thing called winter, where you can have clouds for, weeks at a time or even longer. And trying to have the energy storage for that is not practical. And so, the big solar energy installations that they have to be completely backed up by fossil fuels. So, well, anyway, so really, while solar energy is useful on Mars, we can't really depend on it for a human expedition. We want nuclear power. Okay, now this should not be a fundamental problem. We've had nuclear reactors since 1954, which is to say since before there was color television. But a surface nuclear reactor is different than a terrestrial nuclear reactor, because, for instance, it's much easier to dispose of waste heat on the surface of the Earth than it is in space, because you don't have rivers that you can dump the heat into, or even an atmosphere. You can use a cooling tower. You have to use radiators, but it can be built. And also the weight requirement is much more stringent on a space thing. So that's one thing. I mean, now you want reliable life support systems, but that's not so much a technology as, once again, hardware engineering. Now, if we're talking, though, about settling Mars, okay, then we get into a different problem. Because while, for instance, you take food, a human Mars expedition can just bring its food. Okay, it's simpler to just bring your food than to try to bring a greenhouse to grow the food. And we don't want Mars explorers spending their time as farmers. Okay, so if you're going to Mars, you're going to be on Mars a year and a half, you can bring all the food. You want to recycle the water, because actually that weighs a lot more than the food, but we know how to do that. However, a Mars city, you're not going to want to import the food from Earth. Okay, and that's out of the question. You have to grow the food on Mars. Now, here's the thing. If we look at greenhouse technology, which a lot of people have looked at, and for instance, you may know that Barbara Belvisi has a company called Interstellar Lab with a facility in Paris, and they have greenhouse modules. And these are interesting for a small Mars base, say 30 people, 50 people, perhaps even 100 people. Okay, but there's a big difference between 100 people and 100,000 people, and let alone a million. And when you start looking at the requirements for greenhouse agriculture and the size of the greenhouses necessary to support a Mars city as opposed to a Mars base, it starts looking rather unattractive. I wouldn't say impossible, but really very difficult. And if some people want to grow the plants not at the surface, where you at least have natural sunlight at half the level of Earth, but underground, where you're supplying it with electrical power, is an enormous power requirement. So I think we're going to have to fundamentally advance food production technology to settle Mars. Okay. And let me give you, okay. So there are microbes, there are bacteria, there are yeasts that can take chemicals like methane or methanol, which can readily be synthesized through physical chemical means. Okay. And at high efficiency, and then transform these at high efficiency into protein. Okay. And now this protein is edible by people. You may know of food that Australians eat called Vegemite. Okay. I recommend people try it once. Okay. They like it, but it's actually a food. It's a very nutritious food, actually, produced by yeasts on various organic materials. It can be produced by yeasts on methanol. Now, this is a good food from the point of view of nutrition, but it is not something that people really, well, most people like. But you could feed it to fish and then eat fish, which people do like. In other words, what I'm saying is that we could look at synthetic food. I would call this synthetic food, which could be produced at very high efficiency as the base for things like aquaculture, or even, feed it to chickens and such, and things of this kind. See, because the fundamental problem with conventional agriculture, and by conventional I include greenhouse agriculture in this, is that it's based on photosynthesis. And photosynthesis at the level of the chloroplast is only 4% efficient. That is, only 4% of the solar energy is turned into chemical energy by photosynthesis at the chloroplast level. Now, if you look at the level of a cornfield, okay, it's 0.2% efficient. Okay, because a lot of the sunlight isn't actually falling on chloroplasts, and furthermore, the plant also does respiration and stuff like this, where it's using up some of the food that it's making and all this. So the greenhouse is more about 0.2% efficient. And if you're using the plants to feed animals, it's about 0.02% efficient. Okay. And this compares to chemical engineering processes, which depends on the process, but which are frequently order of 50% efficient. Okay. So instead of going from sunlight to meat at 0.02% efficiency, we can maybe go from sunlight to meat at 10% efficiency. Okay. And that would be enormously enabling for a Mars city. Okay. But now think about this. People say to, people interested in space, why don't you care about human needs? You're just looking all the time at rockets. What about all the poor people in Africa? This. Okay. Well, what could help the poor people in Africa more than cheaper food? Right? In other words, if developing the technologies that make it possible to settle Mars can answer the primary need that human beings have faced since we originated as a species, our most fundamental need, food. Okay. And if you look at all sorts of other things that we do, making them all much more efficient, which is to say cheaper, okay, to meet this much more stringent requirement, there's nothing that would benefit the poorest people on Earth more than to tackle those challenges. So this is why the Mars Society has set up this thing called the Mars Technology Institute, okay, whose goal is to develop the technologies for settling Mars, and which, see, from a technological point of view, we're pretty close to being able to do a Mars expedition now. But for settling Mars, we need some revolutionary technologies. And if we address those challenges, we will massively advance the human condition at the same time.
Dr. Zubrin, this
and by
brings...
the way,
yes, please, go ahead.
And by the way, the Mars colonists themselves obviously will be passionately concerned with solving problems of this kind. And in so doing, they will invent technologies to meet their needs, which will be patented on Earth that will generate income for the Mars colony, but also greatly advance the condition of life of people on Earth.
Yeah, Dr. Zubrin, thank you very much. It brings us to the end of your presentation. We can feel your passion from the other side of the Atlantic Ocean. Thank you very much for joining us. It was an honor to listen to your words. Thank you very much. Please put your hands together for Mr. Zubrin, Dr. Zubrin. Thank you so much. Stay safe and take care. Thank you. Thank you very much for joining us.
Same to you. All right. Thanks for inviting me.
Thank you so much. And now we will conclude the scientific session with some closing remarks of our host, Dr. Bence Mátyás. Bence, can you join me, please, here and say a few words to conclude this session? That was an interesting day. Please.
Thank you, everyone, for joining the GSBC 2025, which is the kickstart of the next conference series, and we would like to report on the progress on this private microgravity experiment series, which we started with the Mayasat, thanks to the exploration company. We are very grateful for the European Space Agency for the representation, also from the Hungarian delegates, the Hungarian ministry, and all of our partners who joined us today, including the Orion Space Generation Foundation. And I would like to ask Bozo, Research Nature, and all of our speakers we can have a group photo here before we are going to continue the event with the gala dinner section, which is going to start at 7 p.m. in the Liz Ballroom. So thank you again, everybody, and see you soon within 2 hours, I think. Thank you.
Something like that, yeah. Thank you very much, Bence. So I kindly ask our speakers to join for a family photo. Thank you so much. And once again, so as Bence said, the gala dinner will start at 7 o'clock in the Liz Ballroom, located on the first floor of this beautiful hotel here at the bank of the Danube on the pest side of the city. And I kindly ask our speakers, organizers, etc. to join for a family photo. Three, 2, 1, and action.
Thank you, everyone.
Thank you so much. Yeah, put your hands together for all of our colleagues and speakers. Thank you so much. So once again, ladies and gentlemen, we will continue the program with the gala dinner on the first floor in the Liz Ballroom, and we will start at 7 p.m. See you there. If you're not attending, thank you very much for being with us, and see you next year. Take care, and bye-bye.